Our planet, Earth, is composed of different layers of rocks. Its core is a dense mass composed of minerals, gases, and hot molten rock, commonly known as magma. Active volcanoes have a heat source in the Earth's crust, where high-temperature fluids circulate slowly. Rainwater seeps into the continental crust, forming underground aquifers. Upon the water's contact with rocks at high temperatures, a geothermal reservoir is created consisting of hot water and steam. Geothermal energy is generated directly through the power of steam, heated and stored naturally in the subsurface. The steam is extracted through deep geothermal wells drilled into the Earth's crust. Because a geothermal reservoir is pressurized, hot fluids emerge to the surface through faults and fractures in the form of geysers, fumaroles, and hot springs, among other manifestations. The use of this resource for the production of electricity is carried out through drilling of deep geothermal wells to depths of around 1,000 and 3,000 meters until the geothermal reservoir is reached. Geothermal wells have an internal telescopic structure with different diameters and are cased with steel pipes and special cement. Geothermal water and steam are obtained directly from the reservoir and flow to the surface due to underground pressure. Once at the surface, steam and water are separated using a cyclone separator, where the denser, heavier water falls to the bottom of the vessel and steam rises to the top by the effect of gravity. Steam is transported through a network of pipelines, also known as a steam gathering system, to Ahuachapan Geothermal Power Plant. The steam is then gathered in the collector and then flows to the last separation filter for water and steam, called the demister, whose function is to remove the remaining liquid droplets suspended in the steam before it enters the turbine and causes the blades to rotate. Going back to the cyclone separator, the geothermal water separated from the steam is brought to a flashing system or flasher. The function of this system is to separate another steam portion from the hot residual water before it goes to the reinjection system. This second separation steam is known as low-pressure steam. It is transported again to a collector and later conducted to the turbine, where both steam pressures turn the blades of the turbine to generate electricity. The turbine rotates at 3,600 revolutions per minute. The rotor of the turbine is coupled directly with a generator, which transforms the rotational energy into electricity. This electrical energy exits the generator and goes to a transformer, where 13,800 volts are converted to 115,000 volts, then delivered to the national electricity grid, and finally transmitted to substations, and from there to houses, factories, schools, and other consumers. The geothermal steam, after completing its function of moving the turbine, goes to a condenser, where it is converted again to water by means of internal cylinders which inject water so steam can be condensed. Once the steam is converted to water, it is pumped to the cooling towers to lower its temperature. Part of the water is used to cool some of the equipment in the power plant, and the rest is piped to Chipilapa, where it is re-injected back to the subsurface. Geothermal energy has become a source of abundant, clean, renewable power generation. Re-injection technology recharges the resource so it can be exploited sustainably through a long lifespan. Geothermal energy is known worldwide as a source of clean power that does not produce toxic gases nor emissions that cause the greenhouse effect. The use of land for the construction and drilling is minimal. The environmental impact is minor and easy to prevent and mitigate. In El Salvador, geothermal energy contributes 25% of the total electricity required by the country to meet its demand and consumption. It represents a better alternative for the future energy supply in the country and the region. La Hell, clean energy for a better planet.